right, well in this video we're going to be looking at some properties of logarithms. Now what I've done here for you, I've completed this table for you already. So go ahead and take a second, pause the video and complete the video, or complete the table on your own, and then hit play when we're ready to talk about it. All right, so if you're wondering how I got these values, basically I'm just taking the log of each of these numbers. The log of 9 is 0.95, the log of 4 is 0.6, and so on. Now I want you to look at these values and I want you to see if you can recognize a pattern. Now maybe you're really good at recognizing patterns. Maybe you start to see something. Maybe you're looking at this and you're thinking, man, this just seems so random. Like 9, 4, 36, 3, 5, 15 across the top. Those don't seem to be in any particular order. You'd think maybe, usually when we set up a table, we go from smallest to largest. And these seem completely random. Well, they're not random. What if I did this? Hopefully you see this. Now, I want you to see if you can make a connection with these numbers and the answer. And these numbers. And this answer. Do you see a connection? Well, maybe what you're starting to see is that when you add these two values, it equals this value. And when I add these two, it gives me this value. In other words, let me just erase some of these highlighters. What we have here, the 1.56, represents the same as the log of 9 plus the log of 4. And the 1.18, that's equivalent to the log of 3, the answer that we got for the log of 3, plus the answer that we got for the log of 5. So when we multiply these two values, the way that we come up with the answer here is we would, or when you take those values to get that answer 15, we'd multiply them. Well, what that translates to in logarithms is we would add those two values to get to that total. So basically what this is doing is this is helping us get to one of those properties. So in this next table, I want you to see if you can come up with the answers. If I give you that the log of 2 is 0.30 and the log of 4 is 0.60, I want you to see if you can come up with just those two numbers using just those two values, 0.3 and 0.6, knowing that log of 2 is 0.3, log of 4 is 0.6, to see if you can come up with what this answer would be, what this answer would be, what this one would be, and what this one would be. So see if you can figure out what to do to get to those numbers. All right, well, let's see how you did. If you notice, this is the same as 2 times 8. So to get that value, we would take the log of 2 plus the log of 8. I'm sorry, 4. There we go. So 8 is the same as 2 times 4. So the log of 2 plus the log of 4 would be equivalent to the log of 2 times 4. Okay, so to get to our answer, to figure out what the log of 2 times 4 would be, we would take the log of 2 plus the log of 4. When you do that, you get 0.9 or 0.90. So 16, what does that represent? 16 would be the same as 2 times 8. In essence, we'd be taking the log of 2 times 8, and to get that answer, we would take the log of 2 plus the log of 8. And we just found the log of 2 is 0.3, and the log of 8 is 0.9. So if I add those together, whoops, I would get 1.20. Let's do the next one. So 32 is the same as 4 times 8. And that would be the same as, so what we'd be finding here is what is the log of 4 times 8. So to figure that out, we would take the log of 4 plus the log of 8. And the log of 4 is 0.6. The log of 8 is 0.9. So when you add those together, we get 1.50. Now, if you did the log of 32 on your calculator, you'd get 1.51. The only reason why is because we rounded here for all of these values to the nearest hundredth. So that means that maybe when we add them together, we end up getting a number where we would end up rounding. So if you're wondering, well, wait a minute, I did this on my calculator, I got 1.51. Well, that's because you're just being a little bit more accurate because the values that I'm working with here, we rounded. All right, let's figure out what 64 would be. If you haven't already figured that one out, one way to look at that, using these numbers as factors of 64, would be the same as 8 times 8 is 64. So in other words, I'm looking to see what's the log of 8 times 8. We'll define that out without a calculator, as I would take the log of 8 plus the log of 8, and log of 8 is 0.9. So if you add those together, we get 1.80. And again, if you do that on a calculator, you get approximately 1.81. So if you didn't follow me, that's okay. That's just leading us to what we call these different properties of logarithms. So the first one is the product property for logarithms. And using these variables, this is just the general form, we would say log base b of the values m times n, just like what we're doing up here. So if I wanted to find the log of 2 times 4, I'd break that up into log base b of m plus log base b of n. Now, the quotient property, use a different color here, says this: if we have the log of any base of m divided by n. Now, if you think about it, multiplication and division, those are opposites of each other. Well, what's the opposite of addition? Subtraction. So this would be equivalent to log base b of m minus log base b of n. It would be in that order. And we have one last property. This one's an interesting one. That if we have log base b of m, and let's say that has an exponent, we'll just call that exponent a. We could put that exponent out in front to simplify it. Now, I want to make sure that you recognize that all of these properties go both ways. Okay, so they go both ways. So sometimes we'll be given a problem like this, and we need to break it up into separate logarithms. Other times, we'll already be given a problem written as separate logarithms, and we're going to want to merge it together as a single logarithm, meaning that we would go that direction. So all of these work both ways is my emphasis there. All right, so let's see how we would use these. Let's look at this first one together. So we have log base 5 of the value a squared times b to the 7th. Now we're going to expand these. Notice the instructions there. We're going to expand these out using those properties. Sometimes you have to use more than one of those properties. And don't try to do too much at once. I'm going to do this in 2 separate steps. So here's what I'm going to do first. I'm going to write it as 2 separate logarithms. Again, basically this first property that we have, the product property, saying that we could pull that apart in 2 separate logarithms to find the value. We would add those 2 together. Again, that was the whole purpose of doing that activity at the beginning. By the way, all of these properties, just like we've been doing before on your notes, might want to put a star next to this. Just remind yourself that you could use this possibly on your note card. All right, so now let's see if we can simplify this or expand this any further. So we have the power property. Remember, that means that we could take each of these exponents and move them out in front of the individual logarithms. So we would really write this as 2 times the log base 5 of a plus 7 log base 5 of b. That would be your final answer for that one. Let's look at the next one. So this one we have division. So this is with the natural log. So we would say this is the same as the natural log of 5 squared minus the natural log of 3. But remember, we have this exponent, so I'm going to put that exponent in front. So we would write this as 2 times the natural log of 5 minus the natural log of 3. How are you doing with this? Do you think you can try this last one on your own? We have both multiplication and division. So if you're feeling up to it, pause the video and see if you can't try this one and see if you can get it on your own. If you're not feeling up to it, go ahead and just listen on through, and I will talk you through it. All right. So first, I recognize that we have multiplication and division. So I'm going to have log base 7 of r cubed plus log base 7 of t to the 4th. So that's our numerator. And then in the denominator, we have a v. So it'd be minus log base 7 of v. Now each of these exponents, remember, we pull out in front of their individual logarithms. So we would say 3 times the log base 7 of r plus 4 times the log base 7 of t minus log base 7, whoops, that 7 got kind of ugly there, of v. There's nothing more to simplify there, so that'd be your final answer. All right, let's bring it up to the end here. So these, we're going to go the opposite direction. That's what I was saying earlier, which means we're going to do it in the opposite order. So let's just go back and let's review. With these, the first thing we did is we separated them into two separate logarithms, and then we put the exponents out in front. So now, before I do anything with the plus and the minus, if there's a number in front of a logarithm, that represents an exponent for the value. So that 4 and the 3 are going to be an exponent for the m and the n separately. So we'd have log base 4 of m to the 4th power plus log base 4 of n cubed, and then we'll just write minus log base 4 of p. Now let's write this as a single logarithm. So now if it's addition, we're going to multiply those values. Now notice something here. I'm just going to go back to the previous examples. Notice how when I had one with multiplication, there's only a single log on the outside. Or this one here with the natural log, we have 5 squared divided by 3. There wasn't the natural log of 5 squared divided by the natural log of 3. It was a natural log of the quantity 5 squared divided by 3. So make sure that you don't just put random logarithms inside the parentheses here. So here's what I mean by that. All of these, if you notice, change my highlighter here, all of these have a common base of 4. So our logarithm is, we're going to have a single logarithm with a common base of 4. Then we have a lot going on in parentheses here. So we're going to be multiplying the m to the 4th and n cubed, and we're going to divide by the other value, which is p. So notice how it's not log base 4 of m to the 4th times log base 4 of n cubed divided by log base 4 of p. Don't do anything weird like that. I've seen students do that, like on a test. They just forget. They get their wires crossed. The whole idea is we're writing it as a single logarithm. The emphasis there on just a single logarithm. So if you have an answer, if it asks for just a single logarithm, and your answer has more than one log, you've done something wrong. All right, let's look at the next one together. So here we have this 3 and this 2. By the way, ignore the negative. Okay, sometimes I know we would take the negative with it. Technically, it would still turn out to be right, but it's much easier if we just leave the minus there. But these are exponents for those values. This would be the same as the natural log of 2 cubed minus the natural log of 5 squared. Now, since we have subtraction here, we're going to combine these as a single logarithm, where we would have 2 cubed divided by 5 squared. Now, personally, I'd be fine with you leaving this just like that. Just like our previous one right up above it. This one here, they didn't have it simplified, so you don't have to simplify yours either unless I ask you to simplify it. But just know that if something happens on Savas, or Savas, however you want to pronounce it, if you feel like you did everything right, but whoops, but it's saying that it's wrong, maybe just go ahead and try to simplify those. So like, for example, for this one, well, let me just write down or. This would be another way to write it. 8 over 25. I'm assuming that Savas would accept both answers as being correct. All right, so with that, I want you guys to go ahead and try this last one on your own. So please, this is one that's is easier, so I think you can definitely try this one without having to use my help. So go ahead, pause the video, but hit play when you're ready to check to see if you've done it correctly. All right, so the first thing you should recognize is that these would be our exponents for those values. This would be the same as log base 2 of c to the 5th power minus log base 2 of n to the 7th power. So since we're subtracting and we write this as a single logarithm, it would be log base 2 of our values, c to the 5th divided by n to the 7th. And that would be your final answer. Well, that's it. So I was hoping to keep these notes under 15 minutes to give you plenty of time to work on your assignment. So hopefully that'll be enough for you guys. So please make sure you work on those assignments so you don't get behind. If you do get finished with your assignment, please make sure you also go back and complete any missing work that you may have.